Assalamualaikum. In this session, we will continue with the UV spectroscopy of the conjugated system. When the conjugated system increase in the molecules, the absorption maximum also will be increased. As we can see, the wavelength numbers here keep on increasing because the conjugation keep on increase. And some substitute also affects the shifted of butterchromic and hyperchromic of unsaturated chromophore. For here example, when you increase the number, the double bond, so the wavelength also will be increased more longer. The wavelength also become higher. And for this one, this type of compound, they have two heteroatom and also double bond, so they have a 2 lambda max with the transition N to anti-pi, pi to anti-pi, with a different wavelength because this is the shorter, the lowest energy, so the longer wavelength. This is quite higher, so that's why the wavelength become more shorter. Next, the most important part in this session is to calculate the absorption maximum, lambda max of diene group. Woodward Fieser introduced this calculation for the energy of diene. So this is based on the pi to anti-pi electronic transition. So we will use this Woodward calculation to calculate the lambda max of diene group. The conjugation double bonds are allylic. We should understand first. This is called allylic. This is called homoannular when two rings and then the diene inside the ring is called homoannular, and this diene is between two rings, so this is heteroannular. And how we know the cyclic conjugated? When we close this one, the double bond at the side of the ring. When we understand that definition, what is homoannular, heteroannular, then we go for Woodward Fieser rules diene, how to begin calculate the lambda max. So we have to understand the first step is know the basic base lambda max for the diene first. For the allylic diene is 217 nanometer. When some of the substitute increase to increment, extended conjugation is plus 30, exocyclic is plus 5, alkyl is plus 5. All this one you don't need to memorize because it always been provided. So let's start with the diene Woodward Fieser rules, how to calculate. Let's start with the acyclic diene. This one, this ring, the base is, just now I said 217, and in this case they have one alkyl group here. You see the cross section here, this is one alkyl, so it plus with 5, so the lambda max will be 222. For next example, we have to find the base first. The first step, find the base. This is the base for acyclic 217, and they have two alkyl group. You can see when I make it as round here, and then they cross where it is cross. This shape, when it is cross, it cross here and here. So this cross is called as alkyl substituent. So alkyl substituent, how many? 2. So 2 times 5 it become 10, because one alkyl is 5, because 2, that's why it become 10. So next step, we have to see exocyclic. Is it present extended conjugation? No. And then next we see whether it's exocyclic exocyclic have or not. How to see the exocyclic presence? So you close your hand for this ring, and then you see at the side or each of the side for the this shape whether they have a double bond or not. For this side have a double bond, so this one is considered as one isocyclic, so you'll be plus with 5. So total of the calculation is 232, this the lambda max. That's how we can calculate the lambda max for the straight diene like this. Next, when we cyclic diene, they have two types. Just now I say heteroannular and homoannular. When heteroannular means diene in between two rings. When homoannular, the diene is like the cyclic ring. So the base is different. The base for heteroannular is 215 and the base for homoannular is 253. Let's see the example. Here, if the given structure is like this, how we start? We have to find the base first, the base of the ring. This is heteroannular, this is the heteroannular, because between two rings, this heteroannular, the base is 215, just now we know. And then based on this shape, you see where the cross line for this shape. So this is the cross, this is the cross, this is the cross. So means they have three cross. Three cross mean represent the three alkyl group. 3 alkyl times 5, it becomes 15. So next we can see whether they have an extended conjugation or not, or exocyclic. Let's see the exocyclic. Is it present? You close this ring by your hand, you see outside this ring whether they have double bond or not at the east side. So in this ring they have one double bond here, so it is considered as one isocyclic. So next, close this ring by your hand and see around here, is it have a double bond at each of the side? So no, so there's no double bond, so only one isocyclic ring present. So total up is 235 for this structure. Next example is for the base for this structure. You see this structure, this is homoannular base. Find the base first and then see when you make it like this shape, where's the cross section for other ring. This one is the cross section, this one is the cross section, and this one. So means 3 alkyl group here. 3 alkyl group, 3 times 5, 15, and the base is 253 for homoannular base. And see whether they have an isocyclic or not. Close your hand for this ring and see outside, is it double bond presents? No. So there's no isocyclic for this ring. Close this ring by your hand, see outside they have double bond or not? Yes, this is one double bond, so it's considered as one isocyclic. 273. Next is example is for this heteroannular. This is the basic of heteroannular, and then see the cross section and then close your hand, this one, see is the double bond outside or not? No. So means no for this ring, and then close your hand for this ring and see outside whether they have double bond. Yes, this is one isocyclic. So total up is 235 for this structure. The base is heteroannular, 215. And next is the example for the compounds that have extra conjugation. Just now we only calculate the base, the alkyl, and also the presence of isocyclic. Now we go more extent. In this case, how many diene group? 1, 2, and 3. 3 diene group. Which one will be considered as a base? So the most considerable as a base is the homoannular. So they have 2 homoannular here. One will be selected as a you can select either here or here. So homoannular base is 253. So others we consider, if you select here as a base, this homoannular as a base, so others is considered as extended conjugation. Other 2 shape is considered as extended conjugation. So 2 extended conjugation times with 30, it becomes 60. So how to know the alkyl? You see the big shape here, where's the cross section? Here, 1, 2, 3, 4, 5. So 5 alkyl group. And then how to see the isocyclic? I say close your hand for this ring and see outside the ring you have double bond? No. For this ring, no. Close your hand for B ring and then see outside B have double bond. Yes, this one is the double bond for B ring. So one isocyclic. And then next C. Close C. Is it a double bond at each of the side? No, this one is not considered because it's not on the this side. Okay, so total is 2, 4, 3. And then again, example for cyclic. For this one, you have to be shaped, and then where's the cross section? Is it have a isocyclic? You close your hand here, see outside, no. Close your hand here, see outside, no. And close your hand, see whether it is at the side of the each of the ring. And they have one isocyclic here, so total is 240. For this is homoannular base, see the cross section, see whether they have a isocyclic for this ring, no. For this ring, have one. For this ring, no. So only one isocyclic. So be careful with the assignment. 3 common error. This compound has 3 isocyclic double bond. How we can consider 3 isocyclic? When you close your hand for this ring, you see outside, no. You close your hand for this ring, this one is 1 isocyclic. So and 1 isocyclic here, there's 2 for this ring. And close your hand for this ring, is there any isocyclic? No. And close your hand for this ring, they have 1 isocyclic. So total isocyclic is 3 for this structure. Okay, for in this case, this is not heteroannular because it's not 2 ring. So this one is considered as acyclic diene, normal diene, straight diene. So and this one homoannular diene would use the base value. Likewise, this is not a homoannular because it's not inside the ring, this is out of ring. This is considered a acyclic diene. That's how to calculate for cyclic and acyclic diene. Next, we go for the alpha beta unsaturated ketone. They have a basic ring for ketone, aldehyde, acid and ester, and the increment also based on alpha, beta, gamma and sigma. So beta for the alkyl group 10, for alpha 10, for beta 12, for gamma 18, for sigma also 18. Let's see the example for calculation. So for this one, this is a ketone. This one is considered as a diene for ketone, and then the cross section is considered as alkyl. So the calculation is 239. And this one you have to make this shape. And another one is extended conjugation. So the cross section is 2 alkyl. Extended conjugation added with 35, and the base cyclic enon is 215. And so how we can know this one is beta or alpha? You have to calculate. From here, this one is alpha, this one is beta, one is gamma, the one is sigma. So in this case, they have beta and sigma ring. So they have different value. So isocyclic, you have to check isocyclic. Close the hand for this ring and see the double bond outside the ring. And this is one isocyclic. And for this ring, is there any double bond outside the ring? No. So only one isocyclic double bond considered in this structure. So total up is 289 for all this value. And next example, make a diene for this ketone and then see where's the cross section and see whether it's present of isocyclic or extra conjugation or not. If no, only isocyclic presents 1 here, so total up is 244. For this structure, same. See where's the from ketone is 1 basic enon 1215, and then next extra conjugation. So this one is double conjugation, 1 extra 39, and where's the cross section is considered as an alkyl group. Alkyl group is not as a normal diene. They have to be position of alpha, beta, gamma, sigma. So in this portion is alpha and sigma. So different value. And isocyclic, close your hand for this ring, see outside, is it have a double bond? No. And so for close your hand for this ring, see outside, this is 1 isocyclic. So total up is 317. Okay, that's all for Woodward Fieser rules. Thank you.